Hi my friends, today we model this part. It has the name fuse cover and the drawing is this one. We start by using this all dimensions. You see radius 12, radius 125, 75 degrees, 20 and 110. New standard millimeters IPT, new sketch, this XY plane, and we draw a horizontal with the length of 110. This line must have the center placed in the center point. Starting from this, we draw a line, keep press the left button, go here, keep press the left button, go somewhere here, keep press the left button and go up to the end. This is not vertical. But it is tangent with that arc. Equal are these two arcs. This point must be placed on the same vertical with the center point. Equal must be these two sides. We place an angle of 75 here, then radius 12, this is radius 125. I move this to the right because I want to place equal between these two sides. One dimension needed, this distance of 20. Okay, finish sketch, extrude 21. Then I have to apply this face draft. All this contour is sloped. Dimension is 8 degrees for that face draft. We select the tool face draft. It is here. We select direction. This is the pull direction. Then we have to select faces. I select this and I place here not 2.5 but 8 degrees. this must be reverted. We select the tool draft, we select the pull direction, then the faces, then the angle of 8 degrees. All faces are sloped. Okay. Now we see that this face is parallel with the other, but the part has this face not parallel with this, but at an angle of 2 degrees. It is plane. The other problem is that this face is curved on about such an arc. You see here, this is curved. Okay. To apply these two steps, we have to respect 2 degrees and the radius of 1000. You see? Firstly, we create the plane at an angle about this end plane, then we'll use the perpendicular plane on this one to create this arc. Let's do this all. We create a plane based on this one and this axis. Here we have to rotate this 2 millimeters. This means 90 minus 2. Then another plane based on this and this axis to be perpendicular, as you can see now, to the other. We hide this one, visibility, and we use this for a new sketch. We draw a horizontal line of 110, but we copied the dimension from these 2 points, this point and this point. Vertical is this end with this end, also this with this. Then we project this line as a construction line, because we place now an arc tangent to this line. On the same vertical is this point with this end, this end with this end. We connect the two and we place the center of this arc on the same vertical with the center point. Good. Now you see here that this is upper beyond this tangency, yes? We have to cut this part. The radius is 1000, my friends. 1000, 1 meter. Finish sketch, extrude with cut all the way through the part. Okay, we hide this visibility, we hide the plane visibility, and we have what we want to have. Next is this chamfer of 5 on 2 millimeters around this contour. We apply chamfer, we select this solution with 2 dimensions, and this is 5. 2 is by default. We select the edge. Okay. We see that the part is empty on 2 faces. The thickness is 2. We apply shell. Shell on 2 millimeters by ignoring this and this face. Okay. We continue with this feature. You see here the detail with all dimensions placed on the plane of symmetry perpendicular here. The width is 10. We open the origin and then this plane, F7. We rotate it to be like in the drawing, and we project this and this. Draw lines. Then we go somewhere here, horizontal, up, sloped, horizontal, down, here, and back. Okay, now we apply dimensions. This is 5. Then we move this for a while because we have a dimension here of 1.5. Then 2 millimeters is this. Seven millimeters is here. 2 millimeters and also 2 millimeters and 7.5 here. 7.5. This is also 2 millimeters and 3.7 is this. Dimensions in the drawing. we have a fully constrained sketch. Extrude. We select this area, symmetrical, on 10 millimeters by default. Okay. We turn back the part, we select this face, and we project this line. We draw a rectangle based on this with this dimension of 7.5. The other is not important. On the same vertical is this with this. Finish sketch. And now we project this on the face, on the curved face. We project, we extrude with cut to this face. Okay. Now we take a look here. You see something, but I forgot to place a dimension here. Let me place it is 1.8. This thickness of a small feature. I place this somewhere here. I said that we focus here by using this one of these two faces. Then we apply symmetry. Okay. We select this face for a new sketch. We project it. Then we draw a horizontal line here. We hover on this line to have a parallel, and we go back here. Okay. Important is to have this point inside the material here. This is why I place on the same horizontal this point with this point. Now that dimension of 1.8, finish sketch, and we extrude this area on the other dimension of 1.8. You see now this result. We continue with placing these two small extensions. Dimensions are here 1.5, 2 millimeters, 2.5. A rectangle here. We use this face. We draw a rectangle, as I said, but in 3 points. This, this, and this. Dimensions 1.5 is this. 2.5 here, but aligned. 2.5, and then 2 millimeters from this line to this point. 2. I want to eliminate this line. Then finish sketch, extrude on 2.5 up, 2.5. This last features must be mirrored 1, 2 about this plane, and we receive this. Okay, the last feature is this emboss. Dimensions are here: 14, 7, radius 1, 8 millimeters here, 16 and 4. We have to place a plane in the air here because we project the emboss to the part. To do this, we select this XY plane and we move it outside of the part here. New plane, new sketch. We draw a rectangle of 16 on tab 14. We place it aligned with the center point on vertical. We draw a triangle three lines. This is horizontal. This distance is 4 millimeters. And this distance is 2 millimeters. Then we apply fillet of 1 millimeter to the corners of the rectangle and also to the corners of the triangle. Equal are these two lines, and on the same vertical is this center with this point. Other dimensions: 9 millimeters from this, not 9 but other dimensions are this distance of 7, this of 8, and we have a fully constrained sketch. Finish sketch. We create a special plane tangent to surface through point. This is the surface and this is the point. Then we use this for a new sketch. The new sketch, I hide the plane and we create our sketch. A rectangle with dimension 16, tab 14. On the same vertical is this point with this point. A distance of 2 millimeters is here. 2. Then we draw a triangle inside the rectangle. Equal are these two sides. 4 millimeters is here. Then we apply fillet radius of 1 to each corner. This corner, this, and this. On the same vertical is this point with a center point. Other dimensions are 8 is this, 7 between 2 points here, and we have a fully constrained sketch. Finish sketch, and we apply emboss. We select this area, we select this option, we select to wrap the face. We want to be attached to a curved face, and we select that face. Okay, very nice. Let's see what is the volume. High properties, physical, update. We select this, copy, close, drawing, double click, and the new value is almost the same. We keep the last value because this is what we did here today. The material is plastic, PPS plastic. Here on this face, another color, smooth light orange. Let me use not default IBL but default lights. That's all for today. Thanks for watching. Bye bye.